All right, in this podcast, we're going over number 9 in the quest having to do with rate law. This is the first time where we've encountered a situation, specifically when we're looking at reactant B, where we're trying to find what its order is, and we cannot hold both A and C constant. We can hold C constant, but we can't hold A constant. So we're going to look at what happens, how we handle it when something like that happens. So first I got to look at what happens with A. So for A, I'm going to take a look at, this is for A, and I'm going to take a look at experiment 2 and 1. And I go to 0.02 concentration from 0.01, so that's a doubling. And if I look at what happens with my rate, I go to a 5 from a 1.25. They're both 10 to the third, so I can cancel that part out. And that gives me a 4. So I'm going to look at 2 to the x is equal to 4, so x is going to be equal to 2. So my order for A is going to be 2. So now I have to look at what happens with B. So I cannot keep A constant. A varies in all the experiments. So I need to find a case where I am, in this case, doubling B, but C is remaining the same. And there's a couple of options there, but I'm going to use experiment 4 and experiment 1. So in experiment 4, my B goes from 0.02, again this is for B, 0.02 down to 0.01, and that's a 2. If I look at what's happening to the rate, it's 8 times 10 to the 4th over 1.25 times 10 to the 3rd. And that is equal to 64. Okay. So now what I have to figure out is how much of that 64-fold rate increase comes from A, and whatever's left comes from B. So it's like this. We know A is squared, and we don't know what B is yet, what the x is for B, but it's 64. So let's look at what happened in the experiment. A, and the difference between experiment 1 and 4, increased 4-fold, and that's squared because it's a second order. And B doubled, right? So, and that's equal to 64. So now I can solve for x, because I'm going to take the 64 and divide it by 4 squared. So 2 to the x equals 64 divided by 16, which is equal to 4. So 2 to the x equals 4, so x must equal 2. So B is also second order. Now let's take a look at what happens with C. So for C, I am going to use experiment 3 and experiment 1, because B is the same. A changes, but we'll just go with what happens, okay? So if I look at what happens to C, it went 2.05 from 0.01, so that's a 5-fold factor increase in concentration. If I look at the respective rates, I go 1.125 times 10 to the 4th over 1.25 times 10 to the 3rd, and I get an answer of 9. So if I look at that, what I again have to do is look at what happens, how much of this 9 came from A and whatever's left came from C. So again, A is squared. In this case, B is staying the same, so I could ignore B. And C to the x equals 9. So A, in this case, if I'm going from experiment 1 to 3, I've tripled A and squared that. C has increased by a factor of 5, so it's 5 to the x equals 9. Okay. So if I look at this, 3 squared is 9. So 5 to the x must have a value of 1 to make them equal, their product equal to 9. And anything to the 0 is equal to 1. So this must be 0th order. Now I'm not going to go ahead and figure out the rate constant for you. Now that you have the orders, you can plug it into the equation and get the answer and figure out which order it is. Okay, I'm going to stop right there.